Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone is doing all right out there. I'm not sure of the title of this lesson. It could be Unit 5, Lesson 12. I'm not sure I'll title it correctly in the title. But what I do know is I know what our goal is. And our goal is we're going to see an example of the three possible outcomes when solving systems of linear equations. We're going to use a graph to investigate what each situation represents. So basically, when we solve a system of linear equations, one of three things can happen. We've only been dealing with one type of situation so far. I wanted to wait till the end of this unit to talk about the two other possibilities, and hopefully we get an understanding of what happens when we solve and how it relates to the graph. So I'm going to hopefully explain the difference between the three. I also want to review, while we're doing this, I want to review solving by transitive, I want to review solving by substitution, and I want to review solving by Gaussian elimination for review. So what we're going to do is we're going to solve this, and then we're going to graph each one, and we're going to see what's happening with the graph. So remember, we're also looking for where the lines cross. That's the key thing here. So we're going to solve this by transitive. I know that it's transitive because both of these equations are equal to y. So if two things are equal to the same thing, then those two things themselves must be equal. So we can set up the following equation. X plus 1 equals minus 1/2 x plus 4. And so now we get into our 6 steps to solve. And we just go through until we get x by itself. So can I eliminate a fraction? Yes, I can. And I can do that by multiplying everybody by the denominator. So everyone gets multiplied by 2 because that's the denominator. And remember, it can either multiply or it can cancel, but it can't do both. So I'm going to be left with 2x plus 2 equals, now these cancel, and I'm left with minus 1x, and then I get plus 8. Okay, now I'm on to step 2. Can I combine like terms on each side of the equal sign? And no, I cannot. I can't put these together, and I can't put these together. Oh my gosh, that's like, can I distribute? No, I cannot because I don't have parentheses. Step 3, can I combine like terms on each side of the equal sign? No, I cannot because I can't put these together, and I can't put these together. Can I get all x's to one side of the equal sign? And yes, I can. I can do that. In fact, I'm going to move the minus 1x to the other side by using addition. So plus 1x to both sides. And now I'm left with 3x plus 2 is equal to 8. Can I add or subtract away a number from the variable side of the equation? Yes, I can. I can subtract 2 to both sides. So minus 2 to both sides. And now I'm left with 3x is equal to 6. Can I divide away a number from the variable side of the equation? And yes, I can. I'll divide everybody by 3. And I get x is equal to, let me write that a little bit lower, x is equal to 2. Now I'm going to use my x value in either equation to find my y value. I like the first or the second equation because there's no fraction, so y equals 2 plus 1, which means y is going to equal to 3. So my solution, or where these lines cross, is 2, 3. I would like to graph this to show that this is in fact where they cross. So I'm going to graph right up here for you guys to reinforce that this is where they cross. And remember, we're looking at 3 possibilities here. All right, one of 3 things will happen. Okay, so I want to use some color here so it's not so it breaks up and a little easier to follow along. I'm going to write my M and B in blue. So M for this problem is, I'm going to put the negative with the 1/2 or the 1, which means I rise in the negative direction, run in the positive, or run to the right, and my b value for this equation is 4. So I begin at 4 on the y-axis, I go down 1, and then I go over 1, 2. I connect my line, or connect my dots, and I've graphed my line, y equals 1/2 x plus 4. I'm going to now graph the second line. I'll do that in another color just so it's clear. My m value, I can put a 1/1. So my m value is 1/1, which means I rise up 1 and I run right 1. My b value is also 1. So I begin at 1, go up 1, right 1. I have my 2 points, and now I can connect my dots and get my line. Again, my lines cross at 2, 3, which is what I found when I solved it using the transitive property. So this graph validates our algebraic work. Now, we have to learn some vocabulary here. Okay? This is called consistent. This is a consistent system, which means it has an answer. So this is a consistent system, and we call it an independent. It's independent, I-N. I gotta learn how to spell. It's independent because it has one solution. I'm rushing. I feel like I'm rushing. Slow your roll. All right. So possibility 1, the lines cross and we get a solution. All right. Let's move on to possibility 2. We're going to draw lines and separate this and make sure these don't overlap. I do apologize in advance. This whiteboard is going to get very crowded with lots of writing on it, but I'm doing all 3 problems next to each other so we can compare and see the difference between the 3 possibilities. I'm reviewing substitution on this problem. Let me see. I think that I need to change one thing here. Let me do this. This will make the problem do what I want it to do. Okay. Alrighty. Now let's, yeah, that's fine. Okay. So what I'm going to do is I'm going to plug this value in for y. So I'm going to write my equation again. So minus 2x plus 2. Instead of a y, I'm going to leave a parenthesis, and I'm going to write everything else. Inside here goes x minus 3. Okay. So again, we get back to our 6 steps to solve. 1, 2, 3, 4, 5, 6. Can I get rid of a fraction? No, I cannot. Can I distribute? With this problem, I can, because I have parentheses. I'm now left with minus 2x plus 2x. 2 times minus 3 is minus 6. That equals minus 8. Can I combine like terms on each side of the equal sign? Yes, I can. I can put these guys together. Minus 2x plus 2x, that's 0x, which cancels out. There's nothing left. And so now I'm left with minus 6 equals minus 8. This is a problem. There's no more variables. And, this is important, and minus 6 equals minus 8 is a false statement. Okay? This is a symptom of one of the 3 possibilities. So we know that the variables canceled out. I can't go any further to solve, and I ended up with a false statement. So what I'm going to do is I'm going to graph these 2 equations and see what's happening here. I do need to rewrite this equation in slope-intercept form, so let me do that over here. So I need to get y by itself. So minus 2x plus 2y equals, let me write that equal sign better, equals minus 8. I add 2x to both sides. Cancels out on the left. I'm left with 2y equals 2x minus 8. Divide the 2 away. And I get y equals 2 over 2x minus 4. Okay, so now I have two equations in slope-intercept form, and I can graph them. So let's go ahead and graph them. Okay, my first equation right here, I know that my b is minus 4. So I begin at minus 4, 1, 2, 3, 4. I know that my m is 2 over 2, so I rise up and I run right from here. So I go up 1, 2, and then 1, 2 there. And I connect. So this is the line that represents this equation. Let me graph my second equation in blue so we can compare. Here I can put a 1 over 1. And let's see here. B equals minus 3. And M equals 1 over 1. So I rise up 1 and I run 1 to the right, beginning at negative 3. Up 1, over 1. These lines aren't going to cross. These lines are parallel. Remember, we're looking at three possible outcomes when solving a system of linear equations. The first possibility, the lines cross. We got an answer. The second possibility, the lines are parallel. So they're not going to cross. I'm not going to get an answer. And this is the symptom that shows this happening. No more variables and a false statement. So let me explain what we call this. Let me find a good marker. There you are. We call this an inconsistent system. This system is inconsistent. Okay, this is inconsistent. And when I say inconsistent, what that means is there's no solution. And there's no solution because the lines do not cross. All right, we got one more to go. Let me make sure I got plenty of room on the whiteboard, and hopefully this time my camera didn't stop filming because it stopped filming on the last time. So I'm going to try and get through this one. All right, so I'm going to put a line off there so we have some space. Maybe I'll pull this over just a little bit further. There we go. All right, so we're going to solve by Gaussian elimination for review. Now, I know that if I multiply this by a negative 2, it'll become a negative 6 and cancel that. So I'm going to multiply everybody by negative 2. Negative 2, negative 2, and negative 2. And I'm going to rewrite my new equation right here. So I get minus 6x minus 6y plus 6. Because it's a negative times a negative, I get a plus 6. And let's see what happens to our equation here. You cancel, so that means that side is equal to 0. These cancel, so that side is equal to 0. Again, no more variables. However, and this is what's different between possibility 2 and possibility 3, 0 equals 0 is a true statement. Okay, so let's graph these and see what's happening so we understand what's going on with these equations and why we're getting a third outcome which is different from the second and different from the first. All right, so think about what could happen. Maybe hit pause. Think about a possibility here. I'm going to rewrite each equation in slope-intercept form. Let me do that up here, so we have some room to graph down here and end this. Actually, I'll start right here. So I have 3x plus 3y equals negative 3 minus the 3x to both sides. I get 3y equals minus 3x minus 3. Divide away the 3 to everybody. and I get y equals negative 3 over 3x minus 1. All right, let me rewrite the second equation. I'll do that up here. 6x minus 6y, oh no, 6x plus 6y equals negative 6. And let me double check and make sure I'm still on this whiteboard here. Just barely on. Okay, so again, I'm going to solve for y here, so I can get it in slope-intercept form. Minus 6x to both sides. I now have 6y equals minus 6x minus 6. Divide everybody by 6. And I'm left with y equals minus 6 over 6x minus 1. All right, I'm going to graph each of these again using two different colors, and hopefully we can see what's happening with the lines, and hopefully that makes sense to why we get this result. Alrighty, so we'll do the bottom equation in blue. I know that my b value is negative 1, and I move down 3 and right 3. Up here, I know my b is equal to negative 1 again, and my m is minus 6, so I go down 6, and I go right 6. So let's graph this and see what's happening here. So minus 1, so I guess I need a graph that's going to go to this direction. So 1, 2, 3, 4, 5, 6, 7, okay. 1, 2, 3, 4. All right, so the blue graph, or the blue equation, I begin at minus 1. I go down 1, 2, 3, and I go right 3. 1, 2, 3, and here's my line. I need a little bit more space on here. I hope that I'm still on the graph. 1, 2, 3, 4, 5, 6. All right, my second line in red, I begin again at negative 1. Here I go down 6. 1, 2, 3, 4, 5, 6. And I go over 6. 1, 2, 3, 4, 5, and 6. It's the same line. This is a symptom of having the same line. Okay? So let me explain what we call this. I really don't have any more room here. Let me steal some of this room here. Okay? Again, I do apologize that this whiteboard got so full, but I wanted you to see all three possibilities at once. So we have the same line. We call this consistent, and we call it dependent. Now, what dependent means is it crosses an infinite number of times, so there's infinity number of solutions. There's an infinite number of solutions. I do apologize again for how crowded this whiteboard got, but again, I wanted you to see that the lines could cross. We would get one solution. The lines could not cross. We'd have no solutions, or the lines could be the same, and they intersect at an infinite number of points. So there's an infinite number of solutions, consistent and dependent, inconsistent, consistent and independent. That was a tongue twister. All right. So again, I hope everybody is doing all right out there. Have a good day, everybody. Bye-bye.